All right, everyone, welcome back. In this video, we're going to do an example of calculating the variance, the standard deviation, as well as some of our other statistics. In this example, we're told the fuel efficiency in miles per gallon of 9 randomly selected cars of the same model and year are given. And with this set of data, we want to find the mean, the range, the variance, and the standard deviation. And so here is our set of data. The first car has a miles per gallon of 35 miles per gallon, followed by 34.2, 36.5, and so on. And so let's go ahead and calculate some of these stats. And so we're starting off with the mean or the average fuel efficiency of these 9 cars. Remember, to find the mean or the average, we just add all of our data values up and then we divide by the total number of data values. And so we're going to have to take 35.0, add to that 34.2, add to that 36.5, and so on. I'm not going to write all that out, but when I type this into my calculator, I will. And we're going to keep adding all these data values together until we get to the last one at 35.1. So add all those up and divide by the total number of data values in our sample set here, which is 9. All right, so if I did that correctly, then the average or the mean should work out to be about 31.656 miles per gallon. So for the sample of 9 randomly selected cars, the sample average is 31.656 miles per gallon. And so now that we know the mean or the average, we can start comparing values within our data set to this mean or the average and answer questions like, well, is 35 really that much bigger than our average? Is 22.3 really that much lower than our average? To really answer that question well, though, we're going to have to talk about the variance and the standard deviation, and we'll be doing that pretty soon. But next, we want to calculate the range. And remember, the way you can calculate the range of a set of data is just take that largest value in your set of data and subtract away from it the smallest value in your set of data. So we can think of the range as like the maximum value minus the minimum value. Let's see, so if I'm scanning the list of numbers here, it looks like our maximum MPG or fuel efficiency is 36.5, and our lowest, I think that's 22.3. And if we take the difference between 36.5 and 22.3, we should get a difference of 14.2. So we have a range in our data of 14.2 miles per gallon that separates the smallest value from the largest value. So up next, we're going to calculate the variance, which is going to help us calculate the standard deviation. And here we have to be careful and remember what type of data set we are working with here. This is a sample of 9 randomly selected cars from the populations of probably millions of cars of this make or model. Well, maybe tens of thousands or hundreds of thousands, maybe not millions of a specific model and year. But anyways, this is definitely a sample we are working with and not a population. So when we're calculating the variance and then the standard deviation, we have to use the appropriate formula. We're going to divide by n minus 1 and not n. So we're going to divide by 8 instead of 9 in this next calculation. And so to calculate the sample variance, we have to start by calculating the sums of the squares of the deviations. And so for that, we have to take the first data value or point in our set and subtract away from it the mean or the average. So that'll look like 35.0 minus our mean or average of 31.656. We have to take that difference and then square it. Then we add to that the square of the next difference or the next deviation. And we're going to keep doing that until we get down to our last data point. So I'm not going to write it for all of them, maybe just the first and the last. But the very last data point has an x value of 35.1. We have to subtract our average or mean of 31.656 from that, square it. We've done that for the other terms, and now we divide by n minus 1, which is going to be 8. And so if we carefully enter this into our calculator, or even more carefully do it by hand, we should find that the sample variance is computing out to be 19.527 repeating. Okay, so we just computed the sample variance, and now that we have that, we can pretty quickly get the standard deviation for our sample just by taking the square root of the variance. Remember, the sample variance is like s squared, while the sample standard deviation is just s, and we can find that by taking the square root of our 19.527 repeating value. And so if we did our calculation correctly, then we should find the sample standard deviation for the set of data is 4.419, and those units would be miles per gallon. All right, so we did just finish our example. We gave everything that the question asked of us, but now that we have this nice summary of statistics, we can do some more interesting analysis with our data. And so remember, our empirical rule said that if our data is distributed in a normal way or with a bell-like curve to it, then 68% of our data should have, in this case, miles per gallon or a fuel efficiency between one standard deviation of the mean. And so remember, our mean or average was 31.6-ish miles per gallon, and our standard deviation was about 4.4. So that means 68% of the cars should have fuel efficiency or miles per gallon between 27.2 and about 36.1 or 36.075 miles per gallon. So now, if we are one of these 9 cars, or we are an owner of one of these cars of this particular make and model, we can now start comparing our fuel efficiency to the samples. And so if we are in this interval between 27 and 36, we should feel pretty good. We have a pretty normal fuel efficiency for that particular make and model and year of car. And so the empirical rule also gives us a couple other intervals to look at. The next one says that 95% of all your data should lie within 2 standard deviations of the mean. So if we take our mean or average X bar and subtract 2 standard deviations away from it, that'll give us a nice lower bound for this interval, and adding 2 standard deviations to our mean or average will give us an upper bound for our interval. And when we take that 31.6 and add 2 times 4.419 to it, we get 40.494. And if we take our mean 31.656 and subtract 2 times our standard deviation of about 4.4 from it, we'll get our lower bound of 22.818. So most of the cars, or 95% of the cars, should fall somewhere in this interval. So we expect that most of the cars, or we expect that 95% of the cars of this make and model and year should have a fuel efficiency between 22.8 and 40.5 miles per gallon. So if we look back at our set of data, we see that particular data point of 22.3 is pretty low, right? It's lower than 22.818. So this car has a unusually low fuel efficiency. So if we were the driver or the owner of that car and we saw that our fuel efficiency was more than 2 standard deviations away from the mean, then we know that we have a pretty unusual fuel efficiency. In this case, a pretty unusually low fuel efficiency for our car. So we might take it into the shop or try to figure out what's going on. Why are we getting so little fuel efficiency?